Welcome to Paradox Lab. Just 250 years ago, humanity knew almost nothing about the solar system beyond what could be seen with the naked eye. We didn't know that Mars once had oceans, didn't know that Jupiter has up to 95 moons, and much less could we imagine that one day humanity would launch probes, land on Saturn's moon Titan, photograph Jupiter's volcanic moon Io, and even launch spacecraft to fly completely out of the solar system. But after 250 years, human understanding has changed more than in the thousands of years prior combined. In today's video, join me in looking back at humanity's 250-year journey of exploring the solar system from the first rudimentary telescopes to modern space probes. From a solar system with 6 planets, increasing to 11 planets, and eventually returning to the 8 planets we know today. We will see how each new discovery has profoundly changed the way we understand our very own home. I invite you to join this exploration. You might be wondering why exactly 250 years and not some other milestone. Well, the year 2026 marks the 250th anniversary of the independence of the United States. From July 4, 1776 to July 4, 2026. Throughout the journey of the past 2.5 centuries, the United States has risen to become the world's leading space power, playing a foundational role in the development of space science and elevating humanity's understanding of the universe to a whole new level. Therefore, 250 years does not only hold historical significance for a single nation, but it is also a monumental hallmark in humanity's magnificent journey of cosmic exploration. Returning to the year 1776, the world had no electrical grids. The steam engine had just appeared. There were no cars, airplanes, or spacecraft. At night, the only light came from flickering candles and oil lamps. But because of that, the starry sky was brighter than ever, unhidden by the blinding glare of electric lights. At that time, humans admired the brilliant beauty of the stars solely with the naked eye. Thus, it is easy to understand why astronomers of that era recognized the solar system as having only 6 planets. Those were the 6 planets that humans could observe with the naked eye, including Mercury, Venus, Earth, Mars, Jupiter, and Saturn. But this perspective was destined to change just 5 years later. In 1781, using his small homemade telescope, the astronomer William Herschel discovered Uranus. This breakthrough discovery expanded the number of known planets in our solar system to 7. By 1801, Ceres was discovered. It is a rather small celestial body with a diameter of 939 kilometers, located between the orbits of Mars and Jupiter. After Ceres was found, astronomers firmly believed they had just discovered a new planet. The number of planets in the solar system had risen to 8. In just the next 6 years, from 1801 to 1807, Pallas with a diameter of 512 kilometers, Juno with a diameter of 254 kilometers, and Vesta with a diameter of 525 kilometers were successively discovered. Consequently, the number of planets in the solar system rapidly jumped from 8 to a staggering 11. For about half a century after Ceres, Pallas, Juno, and Vesta were discovered, they were still recorded in textbooks as planets. However, as more and more similar objects were found, scientists realized that these were not true planets, but rather a completely new group of celestial bodies. Subsequently, Ceres, Pallas, Juno, and Vesta were officially demoted to become asteroids, a newly coined concept designated for small objects that are not planets. This was the first time in history that the very definition of a planet had to change to reflect the evolving discoveries of humanity. In 1846, Neptune was discovered, bringing the solar system's planet count back to 8. Nearly a century later, in 1930, from the Lowell Observatory, astronomer Clyde Tombaugh discovered Pluto. This discovery was quickly recognized by the scientific community, crowning Pluto as the 9th planet of the solar system. For most of the 20th century, the solar system was definitively taught as having 9 planets, with Pluto being the farthest from the Sun. However, by the late 20th and early 21st centuries, the remarkable advancement of telescopes, electronic sensors, and sky survey programs helped astronomers discover an increasing number of icy celestial bodies located beyond the orbit of Neptune. The climax arrived in 2005 when Eris was discovered, boasting a mass even greater than that of Pluto. This discovery forced the scientific community to ask a critical question. If Pluto is a planet, shouldn't celestial bodies like Eris be considered planets too? This debate led to a historic decision. In 2006, the International Astronomical Union, IAU, established a new definition for a planet. Accordingly, a planet must orbit the Sun, have sufficient mass to assume a nearly round shape under its own gravity, and must have cleared the neighborhood around its orbit. Although Pluto met the first two requirements, it tragically failed to meet the third, clearing its surrounding area. As a result, Pluto was excluded from the major planets and became a dwarf planet. Ceres and Eris were also granted this new status as dwarf planets, just like Pluto. The discoveries of objects beyond Neptune's orbit ultimately proved that Pluto is just a part of the Kuiper Belt. This is a vast, echoing region containing countless icy bodies, extending far beyond the orbit of Neptune. This deeply reshaped astronomers' understanding of the solar system, revealing an outer cosmic frontier far more complex than anyone in 1776 could have ever imagined. Over the past 250 years, the number of planets in the solar system has changed multiple times. Not because planets magically appeared or vanished, but because human understanding was relentlessly expanding. From the simple telescopes of the 17th century, humanity has constantly innovated, creating colossal ground-based telescopes perched on majestic mountain peaks and reaching the absolute pinnacle by launching them into the void of space. Telescope technology has revolutionized how humans explore the sky, opening entirely new perspectives on the solar system. When mentioning telescopes, most of us immediately think of Galileo Galilei. It was he who used his homemade telescope to discover the 4 largest moons of Jupiter in 1610, igniting a total revolution in astronomy. But few know that Galileo was not the first to create the telescope. 2 years earlier, in 1608, a spectacle maker named Hans Lippershey built the world's first telescope and became the first person in history to apply for a patent for this groundbreaking invention. Galileo later improved upon it to gaze into the heavens. In 1668, Isaac Newton was credited as the first to successfully build the world's first reflecting telescope. Instead of using lenses like previous telescopes, he used a concave mirror to gather light, ingeniously overcoming chromatic aberration. The major flaw of refracting telescopes of that era. By 1781, in England, astronomer William Herschel, using his homemade telescope, made what was perhaps the greatest astronomical discovery the world had witnessed up to that time. He found a completely new planet, Uranus. This planet lies at an average distance of 2.9 billion kilometers from Earth, far too faint to be recognized by the naked eye. Therefore, it was only when using a reflecting telescope with a diameter of 15.7 centimeters, which he built with his own hands, that Herschel realized the distant star was actually an uncharted world. William Herschel transformed the reflecting telescope from something often considered a mere scientific toy into a profound scientific instrument. There are 2 types of telescopes, reflecting and refracting. Reflecting telescopes use mirrors to reflect light to a focal point where the eyepiece is placed. Refracting telescopes use lenses to focus light. In the 18th and 19th centuries, reflecting telescopes in England, like Herschel's, were the dominant type. In 1846, using his homemade 61-centimeter reflecting telescope, William Lassell, a merchant and astronomer, discovered Triton, the largest moon of Neptune. In 1848, he was among those who discovered Hyperion, a moon of Saturn. By 1851, he went on to discover Ariel and Umbriel, 2 moons of Uranus. The early era of modern astronomy evolved just like that. From the homemade telescopes of passionate amateur astronomers, humanity for the first time learned of the hidden moons orbiting the distant gas giants. Lassell's successes demonstrated the immense potential of the reflecting telescope. But at the same time in Ireland, an even more magnificent machine was being constructed. It was the Rossi telescope with an aperture of 83 meters, the absolute largest telescope in the world for over 70 years. The primary mirror of the telescope was about 13 centimeters thick and weighed nearly 3 tons. To keep this giant mirror from deforming under its own crushing weight, engineers had to design a highly specialized support system, a crucial evolutionary leap in telescope manufacturing. The entire telescope tube was about 16.5 meters long, with a total weight approaching 12 tons. Thanks to its unparalleled light-gathering ability, the Rossi telescope for the first time allowed humanity to clearly observe the glorious spiral structure of many nebulae, including the M51 galaxy. This discovery later became one of the vital pieces of evidence, showing that galaxies inherently possess spiral structures. However, while England pursued reflecting telescopes with massive mirrors, in the United States, astronomers still placed their absolute faith in refracting telescopes. The pinnacle of this trend was the Yerkes Observatory. Inaugurated in 1897, the Yerkes Observatory housed the world's largest refracting telescope at the time. It featured a double-lens refracting telescope with a massive 40-inch aperture, equivalent to 1.02 meters. Additionally, the observatory included laboratories, workshops, and a library to fully support research and education for the University of Chicago. Since opening its observing dome to the night sky in 1897, Yerkes not only photographed stars and planets, but also delved deep into researching their composition, chemical nature, and evolutionary processes. From here, a generation of brilliant minds who profoundly influenced astronomy and physics were trained, including Edward Emerson Barnard, Edwin Hubble, Gerard Kuiper, Nancy Grace Roman, Carl Sagan, and even Albert Einstein. Yet, the success of Yerkes simultaneously revealed the undeniable limits of the refracting telescope. As the apertures grew larger, the massive lenses became far too heavy, incredibly difficult to manufacture, and prone to severe deformation under their own weight. To continue peering deeper into the infinite cosmos, astronomers were forced to return to an idea that Isaac Newton had laid the foundation for over 2 centuries prior, the reflecting telescope. And then, in 1917, a historic turning point emerged with the 100-inch Hooker telescope at the Mount Wilson Observatory. With a primary mirror 2.5 meters in diameter, the Hooker became the world's largest telescope at the time. But what etched it into immortality was not its sheer size, but the discoveries that completely shattered and reshaped human understanding of the universe. It was with this very telescope that Edwin Hubble proved that the Andromeda Nebula was not located within the Milky Way, but was a vast, independent galaxy, sparking the world-altering realization that our universe contains billions of other galaxies. Just a few years later, he continued to discover Cepheid variable stars, which have a special relationship between their period of variation and their maximum brightness. The longer the variation period of a Cepheid star, the brighter it is in reality. Knowing their true luminosity, Hubble could compare that to the apparent brightness they displayed in the night sky through the Hooker telescope, and subsequently deduce their staggering distances, and the distance of the galaxies containing them. Hubble and Humason then measured the redshift of these galaxies, discovering that almost all of them were rushing away from us. From this, a breathtaking, revolutionary conclusion was drawn. The universe is not a static, silent void, but is actively expanding. In the second half of the 20th century, astronomers began identifying the absolute best locations to place massive optical telescopes, seeking refuge far away from the smoke, dust, and blinding light pollution of booming cities, to the point where even the mountain peaks in California could no longer escape them. Today, the world's finest telescopes are concentrated on the pristine summit of Mauna Kea, on the desolate high-altitude peaks in the Atacama Desert of Chile, and across the Canary Islands. But to look the absolute deepest into the universe, without being hindered by Earth's atmospheric veil, nothing is better than a view from space itself, and the Hubble Space Telescope, named after the legendary astronomer Edwin Hubble, and launched in 1990, overcame every conceivable obstacle to propel the advancement of science. The Hubble Space Telescope has a diameter of 2.4 meters, and its 5 main instruments observe across the ultraviolet, visible, and near-infrared regions of the electromagnetic spectrum. It operates silently in low Earth orbit, about 537 kilometers from our planet. Hubble's scientific value to humanity is simply immeasurable. It has made over 7 million individual observations over the past 36 years, and 23,000 research papers based on those observations have been published by a global community of nearly 29,000 astronomers. Yet, as our questions about the origins of the very first galaxies and the violent formation of planets grew larger, Hubble gradually revealed its technological limits. Humanity desperately needed a telescope that was stronger, larger, and capable of seeing further back into both space and time. That is the exact reason the James Webb Space Telescope was born. Launched into the dark unknown on December 25, 2021, the James Webb Space Telescope is often considered the rightful successor to Hubble's incredible legacy. However, rather than replacing it, these two majestic instruments work to complement one another. While Hubble observes primarily in visible and ultraviolet light, James Webb is perfectly optimized for infrared wavelengths, allowing it to peer right through thick veils of cosmic dust and observe the ghostly forms of galaxies that formed just a few 100 million years after the Big Bang. At the same time, James Webb is currently analyzing the atmospheric composition of alien exoplanets, bringing humanity tantalizingly closer to finally answering the ultimate question regarding the existence of life beyond Earth. From the aristocrats and astronomy lovers who spent their own fortunes to build telescopes in the 17th century, to the devoted scientists who dedicated their entire lives to expanding the fragile boundaries of knowledge, the telescope has relentlessly changed how humanity perceives reality. Today, thanks to modern observatories on the ground and out in space, exploring the cosmos is no longer the isolated privilege of a few, but has become a shared triumph followed by millions worldwide. Scientists today don't just observe the universe in ordinary visible light. They utilize observations in infrared, ultraviolet, radio, X-ray wavelengths, and more. All are directed toward a single unifying goal: to be able to see as much as humanly possible of what lies deeply hidden within the cosmic dark. Alongside the evolution of the telescope, aviation and space technology have also taken extraordinary, unimaginable leaps. In 1776, when the United States had just declared independence, humanity couldn't even conquer the sky above our heads. It wasn't until 7 years later that the first hot air balloon flight was accomplished. At that time, surely no one could have ever imagined that less than 2 centuries later, humans would set foot on an entirely different celestial body. Yet, on July 20, 1969, the seemingly impossible became a glorious reality when the brave astronauts of Apollo 11 first landed on the moon, marking one of the greatest technological and spiritual achievements in human history. From then on, humanity no longer just passively observed the solar system through telescopes. We began to boldly explore it directly with autonomous probes and manned missions. Dozens of robotic emissaries have been sent to Mars, from Spirit, Opportunity, Curiosity, Insight, all the way to Perseverance, helping to dig up the billions of years of history buried in the red planet. The Huygens probe successfully descended through the thick atmosphere of Titan, Saturn's largest moon. Meanwhile, legendary missions like Voyager 1, Voyager 2, and the Pioneers continue to streak past the beautiful gas giants to reach the freezing, distant reaches at the very edge of the solar system and out into interstellar space. These daring expeditions have shown us a profound truth. The solar system is not immutable. Every celestial body is endlessly, dynamically changing over time. Even our faithful moon is gradually drifting away from Earth at a rate of about 3.8 centimeters per year. That means compared to 250 years ago, the moon today is roughly 9.5 meters further away from us. Every single new discovery is a humbling reminder that what we know about this vast universe is still just a tiny, fragile fraction. Perhaps 250 years from now, our descendants will look back at today's monumental discoveries, just as we look back at the world of 1776, as merely the very first tentative steps on an endless journey of cosmic exploration. By then, the things we consider groundbreaking today might just be elementary common knowledge, eagerly making way for deeper understandings and revelations far more extraordinary in humanity's unyielding quest to explore the universe. Thank you for always accompanying me in every episode of Paradox Lab. If you found this video helpful, please don't forget to leave a like for the channel, subscribe, and share the video with your friends so that more people can join in exploring the fascinating wonders of science and the universe. Me also eagerly looks forward to receiving your constructive feedback. Every single comment is a vital source of motivation for the channel to continuously improve and deliver even higher quality content. Thank you so much for taking the time to watch. And now, goodbye, and see you again in the next episodes.